For the first part of this second half of Unit 6, we are going to take a look at functions and a little bit more of what we can do with them, starting with function operations. Then we're going to jump into composition of functions, finding inverses of functions, and then lastly, graphing radical functions and their transformations. Operations of functions, pretty straightforward. Adding, subtracting, multiplying, and dividing the functions, doing the math. Something to note here with function operations, the domains of the sum, difference, product, and quotient functions consists of the x values that are in the domain of both f and g. Also, the domain of the quotient function does not contain any x value for which the function equals 0. We are not going to focus so much on that right now. We will when we get to the rational functions unit. Basically, what that is saying is, in a division problem, you cannot divide by 0. So what would make the denominator equal to 0? We're not going to get that crazy complicated yet. So let's hop into these examples. As we are going along in the video, I will ask you to pause and work through some and then resume to check them in order to be successful. That would be the best plan versus just copying everything down. And we want you to be successful when we take this last assessment. So let's look at the first one here. So adding and subtracting. F of x equals 4x plus 7. And this should say g of x equals the square root of x plus x. What are f plus g of x and f minus g of x? Well, to find f plus g of x, I am just going to take my two functions and add them together. There's my f function, and then I'm going to add to it my g function. I just take a look at what I can combine together for like terms. The 4x and the x can be combined together to make 5x. And then I've got our 7 and a square root of x. So that is my f plus g of x. Now let's take a look at f minus g of x. So now I'm going to take my f function, which is 4x plus 7, and I'm going to subtract my g function, which is the square root of x plus x. So I'm taking away that entire function. So here I need to distribute my negative through. And so that leaves me with 4x plus 7 I just bring down, and then minus a square root of x and minus an x. Combining like terms again, I've got 4x minus x, which gives me 3x. I still have a plus 7, and then I have a minus square root of x. I would like you to pause, work through the next one, and then come back to check. For f plus g of x, you should have gotten 2x squared plus x plus 5. And for f minus g of x, 2x squared minus x plus 11. If you don't get an answer that you should have, make sure you always pause the video to take a look back at your work and compare it to the work that is presented here to make sure you're on the right track before you resume. Okay, let's do some multiplying and dividing. And again, forgetting my G's here, I'll have that. So make sure you add those in. I got it on the next one. So if that's missing in your packet, please fix that. All right, so in this first one, we are multiplying together. Okay, we are multiplying the two together. So I need to multiply x squared minus 9 and x plus 3. It is a binomial times a binomial, which means I can either FOIL it or I can box it out. I'm a fan of the box. X times x squared would give me x cubed. As you can see, I don't have any like terms. And so my final answer is x cubed. We should always write in standard form still, plus 3x squared minus 9x minus 27. Now let's do our division. So my f function is my numerator. That is x squared minus 9. My g function is my denominator, x plus 3. Well, I can simplify this, but probably not how you're thinking. I can't cross off an x or take the 9 and 3 divisible by 3. What I have to do is I'm going to factor my numerator. That is a difference of squares. And so that becomes x plus 3 times x minus 3. My denominator is going to stay x plus 3. Now I can simplify factors. Okay, I have an x plus 3 and an x plus 3. Okay, those are things that I'm multiplying by. So then what I have left is just x minus 3. So that is my final solution there. All right, take a look at the next one. This one's a little trickier. Same idea, but a little more work involved. All right, for our product, you would have gotten 9x cubed minus 30x squared minus 23x minus 4. And for our quotient, x minus 4. If you are good to go, turn the page and continue on. All right, composition of functions. So you're going to notice this symbol in here, okay? That is not a multiplication, okay? It is not multiplication. What it is composition, following. So what g following f of negative 3 means is you are going to first find f of negative 3. So I'm going to, in my f function, I'm going to plug in negative 3 wherever there's an x. So that would give me negative 3 minus 5, which gives me negative 8. Now, okay, g following f of negative 3 means now I'm going to find g, but not g of negative 3. I'm going to take the result I got from f of negative 3, which was negative 8. So I'm going to find g of negative 8. So I plug that in for x, and it's best to put it in parentheses. into my g function. Negative 8 squared gives me 64. That is my final answer. All right, try the next one. Pause, calculate it out. Your final answer should be 4. You first plug negative 3 into the g function to get an output of 9, and then plug 9 into the f function to get an output of 4. All right, this next section, a little bit different. So here I want to find f of g of x. So I always work from the inside out on these. So what that means is I'm taking my g function and plugging it into my f function. So this means actually the same thing as f following g of x. Okay, so I'm going to take my g function. My g function is x plus 3. And I'm going to plug that into my f function wherever there's a variable. So instead of writing x squared, what I'm squaring is what I replaced my x with, which is x plus 3. And then don't forget to bring down the minus 9. The x plus 3 squared, we need to expand that out. It is a binomial, so you either box it or FOIL it. Hopefully, maybe some of us at this point can do that mentally. X squared minus 6x plus 9. Okay, that's what that equals. And then I got to bring down my minus 9. Those zero each other out. And so my final answer is x squared minus 6x. Sorry, that shouldn't be a minus. Plus. Okay, I want you to try the next one. So the next one, we are going to take the f function and plug it in to our g function. So instead of writing x plus 3, I'm writing x squared minus 9 plus 3. So x squared minus 9 plus 3, combine our like terms, and we end up with x squared minus 6. All right. I would like you to try the next two completely on your own. Hit pause and then come back to check them. Hopefully, with the one on the left, you did simplify. If you didn't, take a look at what I did. Okay, I had to get common denominators. You can think of 5 as 5 over 1. My common denominator would be 3, so 5 over 1 is equivalent to 15 over 3. Once we do have common denominators, I can add and subtract fractions. My denominator stays the same, and I do the math. X plus 3 minus 15 simplified to be x minus 12 over 3. The next one, a little bit easier. X minus 5 plus 3 over 3 simplifies to be x minus 2 over 3. All right, your task is to complete the next page, page 3 in your packet, function operations and composition of functions practice. When you are completely done with it, then you will check it off of Canvas and then continue on with the next video. Good luck.